Okay, so for the next question, we have a question on the region of reachability. This is a theme that appears sometimes in these projectile motion questions, and sometimes they're even a bit more challenging, but this question makes it quite simple. So projectile is launched at some fixed velocity v naught, right? And the only thing that can change is the angle of the projectile. So you can see over here the diagram. There's a few trajectories drawn out for you, and we're supposed to find the region that this projectile can reach, and it's highlighted in the dotted parabola over here. And one can show rigorously that this dotted region is a parabola itself, right? And specifically, you can show it using something known as envelope, right? You can search this Wikipedia link. This Wikipedia article tells you how to find an envelope for a family of curves, and if you apply to that, you get that envelope, right? The region of reachability is a parabola. But anyway, this question tells you that given is a parabola, right? You just need to find the coefficients of the parabola. So the question simplifies it for you because you don't have to prove there's a parabola, but you just have to find the endpoints, right? Basically the endpoints here, and there'll be enough. Okay. So first let's notice if we have the parabola over here, a y equals to a plus b x squared, right? The two extremities or 2 points on the parabola would correspond to the one where x is 0, right? This one. So x is 0 means that y is a. So in other words, this point over here, right, is 0a. Right? And the other point over here would be where y is 0. And when y is 0, it'll be x is equals to minus b over a square root minus b over a. Okay, so wait, sorry, I'm messing up the math here. It's actually square root a over b. Okay, so it may seem like this is an imaginary number, but remember that b is less than 0, right? So b is less than 0. That implies that this quantity inside here, right, a is positive and b is negative. So this quantity inside here is positive, and so x is actually plus minus of square root negative a over b. So all that we are left to do, so this, okay, let me just highlight this. So this is square root minus a over b 0. Right? So that all that's left to do right now is to match it up with is to find expressions for a and b in terms of the v naught, right? The initial velocity. Okay, so we can use the fact vertically is very easy, right? Vertically, the first one vertically is just the vertical case is just the maximum height of a projectile if it's vertically projected upwards. So in this case, right, you can use kinetic energy perhaps. So like the maximum height, right, where the projectile comes to a stop, right, is where the kinetic energy is 0. So that means all the kinetic energy has been converted to GPE. So half mv squared equals to mgh. That will imply that v is square root of 2gh. Or actually no, we don't even need that. Sorry about that. It's actually just h is equal to v squared over 2g, right? Because we're interested in the height at which it goes to, right? So that means that a is equals to v squared over 2g, v naught squared over 2g. So this is okay, this is okay, this is okay, this is not okay. So d is eliminated, and e is okay. So now we need to find what b is. Okay, so b, so using this for the first point that you can see that this point, right, the x-intercept for the region of reachability parabola, the dotted parabola, is the furthest distance that the ball can go. And the furthest distance we know is achieved by throwing it at an angle of 45 degrees, right? So if you throw it at an angle of 45 degrees, it goes the furthest. So this region, so 45 degrees, right? The range derived previously in the notes, we saw that the range is u squared over g sine 2 theta. right? So that means we know that the length here is u squared over g. Okay, so are we then tempted to say that b is u squared over g, right? The answer is no, right? Because this is v naught squared. The answer is not v naught squared over g, because this is the x, right? This is equals to x, which is equals to square root of minus a over b. And so we need to solve for b. We know a already, right? A is v naught squared. A is v naught squared over 2g. So we just need to express things in terms of b, right? So v naught to the power 4 over g squared equals to minus a over b, and they will imply that b is equals to minus a over v naught to the power 4 times g squared. Substituting a into this, we get minus g over v naught squared times 2, right? So the answer is hence E. So the answer is E. Okay, so this is a relatively simple question. We just need to calculate the two endpoints, right? The highest it can go and the furthest it can go, and just match it up to the parabolic equation for the envelope. Okay, so yeah.